Okay, taking a look at diode isolators today in the shop. I get a lot of questions about these. A lot of the questions pertain to voltage drop, but the one I had today was my solar charge controller I think is bad, and the solar charge controller wasn't bad, it just needed a voltage at the input stud to work, and I'll get to that in a minute. But what I want to show here is the input right here. This wire is at 14.7 volts, roughly 14.6. Let's make it 14.6. The amperage, the current flowing out of the charger is 9.1 or 9.2 amps at 14.6 volts. But if we look up here, we can see that we're only getting 13.8 at the battery terminal, which is horrible. It's going to lead to chronic undercharging. So what I'm going to do here is I'm going to turn the battery, the charger voltage up to see what it takes to get 14.6 at the battery. Okay, now we're at 14.6 at the battery. This is the battery side of the diode isolator. And you can see that we need 15.5 volts on the charge side, whether this be an alternator or a battery charger that doesn't sense battery voltage or whatever it may be. And our charge current has also gone up. So we saw before that we're only at about 9 amps of charge current at 14.6 when the battery was seeing 13.8. This relation, by increasing this voltage here to compensate for that voltage drop in the battery isolator, also gives us more current at the battery. Now if I drop this back down to the 14.6 range, current's going to drop back, it'll come back up again. But we can see again that we've got 14.6, 13.8, we've got about an 0.8 of a volt drop on this particular diode isolator. Now the one thing that I do want to mention as well is this is important. We're sensing 13.6 at the output. See, the input from charge sources comes in here, and then it splits and goes to 2 battery banks. Inside here are 2 diodes, which are basically check valves. They don't allow the current to flow from battery to battery. They allow current to flow from charge source to 2 batteries. The problem is all modern chargers, or most all modern chargers, and modern solar controllers need to see battery voltage to turn on. So if we feed a solar controller here, or a modern battery charger, it needs to see a battery voltage to turn on. And the reason for that is if there's a short in a battery, we don't want a battery charger or solar controller turning on and causing an explosion or any further damage. So this is another problem that's inherent with diode isolators, and one that I run into quite frequently, and one that prompted this video. Customer's trying to install a solar panel and his controller wouldn't kick on. His controller wouldn't kick on because there's no voltage at the input stud when there's no loads. So in any event, that's my little short blurb on diode isolators and why we pretty much no longer use them in the marine industry.